Now, after the three-way handshake, the communication is established between the browser and the server. Okay, and you will start to send what we call the first request of HTTP. Right? So we are looking at the HTTP protocol. You can see that on packet 13, okay, Wireshark has identified the protocol to be HTTP. HTTP stands for Hypertext Transfer Protocol. Okay, and the destination is the server address that we get. Okay, the server, the web server. And the summary is that I'm trying to do a get slash. Okay, get slash is getting the root, get the root of this server, and I have the version of the HTTP protocol that I'm going to use. Okay, HTTP 1.1, right? Uh, so very simply, you can see that we are looking, we are getting this request comes from the port 62955, which is the port that we have already set up in our three-way handshake. We're going to the destination port, port 80. Okay, so port 80 is a HTTP port. So anything that is port 0 will be marked as HTTP from the for Wireshark. Right? Now, there's a whole lot of things that the HTTP will require, and these are what we call the HTTP header information. It basically tells the server that, okay, I'm going to get the root, okay, and I'm going to get it for this host, and I am coming as a user agent Mozilla 5.0 using Chrome. Okay, you can know that I'm Chrome. And as a Chrome browser, I am able to accept text, I'm able to accept application, and blah blah blah. So, and I can accept English, I can accept EN English from Great Britain, and also English from US. Okay, and there are many other type of encoding that I can accept. I can accept gzip, I can accept deflate, and so this is how the client tell the server, who am I? What are the things that I can accept? What are the things that uh, uh, you can send to me, right? So this is the detail of the web request. Now, if you click on the left-hand side and drop down, over here is a much easier to understand way of displaying, rather than looking at the text over on the left-hand side. The right-hand side has a much nicer looking. So this is the whole text that's been sent to the server, right? Again, it tells the server, it tells us that the response comes in frame 15, and after frame 15, the next request in the same stream is in frame 16. Right? So Wireshark is very useful in allowing you to chain the requests together. So this is the first request. I'm getting the root. Right? Now the server acknowledged this request. Okay, you can see that the server acknowledged this request. Right? The server hasn't sent anything yet. So basically, what happened on the network is this, right? The client send a whole packet of requests to the server. The server reads it, quickly send an acknowledgement that tells the client that, okay, I receive it, do not resend again. And the TCP layer basically take this whole request and chuck it to the server, right? So, but before the server can process it, it sends an acknowledgement back to the client that says, okay, I receive it already, right? So wait for the actual response to goes back to you, right? So this is what the network is telling us. Huh? Now, the server responds, and right now we're looking at frame 15. We're looking at frame 15. Okay, the server, the HTTP server responds back, right? So you can see that the Wireshark is very smart over here. It doesn't label the acknowledgement as HTTP. It only label it as TCP because it is only an acknowledgement packet. Okay, it has no other data itself, right? Although it also goes from port 80, it doesn't label this packet as HTTP. So in a way, Wireshark is pretty smart on this. Now let's take a closer look at the response itself. Right? The response back from the server is HTTP 1/0 200. So the first thing the server tells the client is this: 200. This is a code. 200 means good, okay, right? Okay, the thing is ready, right? I'm going to give it to you, okay? And I have some other information that I want to share with you. I am an Nginx server running on Ubuntu. Today, the time now on the server is 18 March, 9:51 GMT. I'm going to send you a content. The content type is HTTP, is text/HTML. And this HTML page is last modified on the 11th of March, 07:19 GMT. The transfer encoding is in chunk, right? So I'm going to send you in chunks. And it will be in gzip encoded, right? That means I don't send you in plain text. I package the whole file into a zip file. I'm going to send it to you, okay? And it is in a chunk, right? The chunk meaning is in a kind of like a binary form, right? It's a binary form. So very kindly that the Wireshark also tells you that the content is 532 bytes, and after you expand the zip file, it will become 858 bytes. And so they kind of like save 300 bytes because it zip out the details, right? Now, when you first look at the packet itself, okay, you will see it in a compressed form. You see, this is a compressed form, right? So Wireshark hasn't go and expanded for you yet, right? You see this in raw, whatever you see on the network layer itself, so it's in a compressed form. However, if you happen to click on this line-based data, it will start to expand the zip file for you, right? So let's take a look at this. Okay, so this is the zzip file. Okay. When you click on the line-based data of these 30 lines, okay, it will expand it out, and this is exactly what you see in the source, right? This part, I copied it out from the view source of a Chrome browser. So you can see whatever you see on the network itself which is exactly the same. Now, of course, you have the /n. /n means it's a new line, right? So other than without the new line is not displayed on the view source. Okay, it is exactly the same, right? Word for word, letter for letter, right? Letter for letter. Okay, so this is exactly how the server gives the browser, and the browser load it into the source, and it will start to render it in the web page itself, right?